Hi guys, so this is Vicky again, and this is the second part of the 5 chemical reactions where we are going to go through the single replacement and double replacement. So single replacement is basically if you are already in a relationship, for instance, A and B, and you decide that it's just not for you and you want to find a different partner and you want to kind of date around. So what you do is you are going to change partners. So a and C are going to get together, and B will be all by itself. So A and C and B. Do you see what just happened? Right? Okay, super, super easy. So here's an example. Let's just say we have hydrochloric acid and we have zinc. And it just so happens that zinc wants to be paired up with someone else, right? And H, the proton, and the chlorine, they don't want to be together anymore. So now what we have to determine is that zinc, because it's a metal, it has a potential of becoming a 2 plus charge, right? So it's a cation. And the proton and the chlorine obviously are going to be a +1 and a -1 charge because we know that that's how ions work. So if you look at it, we want to pair up the positive and the negative together. And because zinc has the potential of becoming a positive cation, we want this to be paired up with the chlorine anion. Okay, so what happens is we switch partners. So zinc, which is a 2 plus charge, will pair up with chlorine, which is a -1 charge. We swap them and drop them, and we end up with zinc chloride. When I said swap and drop, we're talking about this. You swap and drop, okay? And then hydrogen will be all by itself. But remember Hunkelbrief, Brinkelhoff, Hunkelberry Finn. So Hunkelbrief, Brinkelhoff, Hunkelberry Finn. So remember that these are all diatomic molecules, so they never, ever, ever exist on their own. Remember, you had to memorize this, must be memorized. So again, hydrogen down here will not be by itself. It will be paired up with itself, okay? So that's it. So if I were to just clean this up and rewrite it down, it will be HCl plus zinc yielding zinc chloride plus hydrogen. And then I just have to balance it. I have 2 hydrogens here, so I put a 2. I have 2 chlorines here, so by distributive property, I have 2 chlorines here. I have 1 zinc, and that's it. Super, super easy, right? Um, what I want you to notice is that zinc here, it used to be an atom, but now here it has become an ion. So it is a 0 charge becoming a 2 plus charge. And when it goes from here to here, it's undergoing a reduction oxidation reaction. And because it lost electrons, obviously zinc underwent an oxidation reaction. In another sense, here hydrogen was an ion, it was a hydrogen ion, right? And then here it's an atom because it's a diatomic molecule. So going from here to here, it gained electrons, right? And because it gained electrons, it underwent a reduction reaction. So single replacement, from this point on, you will remember this as being the redox reaction. Okay? Cool? Cool. All right, let's continue with number 5. Number 5 is double replacement. So double replacement, there are 2 types of double replacements, okay? But the main idea here is this. Double replacement is when you go on a double date and you end up with switching partners, okay? So you have A, B, and then you have CD, and then you go and you switch partners because you decide that it would be more fun to switch partners, and you end up with CB plus AD, okay? And if you see, I switched the B and the C here because I am trying to be um, conscious that A is a cation, B is an anion, C is a cation, and D is an anion. And we always like to put cation first and then anion, right? Okay, cool. So basically what just happened here is that in a chemical reaction, and usually they happen in a beaker or a test tube or whatever, so in a container, what happens is A comes in, Okay, and B comes in. They used to be partners. The second they come into the pool party, they start to split apart. And then C comes in, D comes in again, same idea. They split apart. And then they kind of like roam around and they find their different partners. So they find different partners. So they get together, and then this one and this one are going to get together. And then it just so happens that one of them will end up getting in a very committed relationship, and they become a solid couple, and they precipitate out of the chemical reaction. And hypothetically, let's just assume that A and D get married and they become a solid couple. And so the solid or the precipitate will actually fall to the bottom of the flask, and they will leave the market. So they will leave this solution, okay? And that leaves B and C roaming around, still looking for extra partners, or still not 100% committed to each other. So we call these the spectator ions. Okay? Cool, cool? Cool. So in this scenario, double replacement will be a precipitate type of reaction, okay? Now, how do you know which one gets married and which one becomes a spectator? So in this sense, we said that this was the solid and these are going to be the spectators because you're still kind of like, roaming around in the solution. Like, how do you know A and D is going to become the precipitate? Well, you know this because we have this thing called the solubility test. Okay, and you kind of have to memorize it. And we have these rules, and this is what's going to determines the precipitate. So for the sake of the SAT 2, you do have to know a few of them. For the sake of the AP, you do have to know a few of them as well. But for school chapter tests, most of the time your school teachers will provide you with that information. So you don't really have to memorize it. You just have to be able to understand it and find it. But if you memorize these easy 4 rules, because usually when the teacher gives it to you, it's going to be like 8 rules, 9 rules, sometimes even 12 rules. But if you memorize the basic 4, it'll make your life so much easier. Okay, so let's see. The first rule, it's going to be compounds where they are always soluble, which means that they are never going to be in a solid relationship. They are always spectator ions, and so we identify them, we symbolize them with an AQ, which means aqueous, which means that they're still in water, roaming around and looking for a partner. Okay, so if and every time you have a compound that is paired up with any one of these, you will be an aqueous spectator ion, okay? And they happen to be anyone on the first column of the periodic table. So lithium, sodium, potassium, rubidium, cesium, and francium. The way I memorize it is Lena. Lena is very slutty, and so we don't ever get in a solid relationship. So she's always looking around for a new partner, okay? So that whole column, the Lena column or the first column of the periodic table, is always going to be aqueous. All right. Also, NH4 plus, which is ammonium. Ammonium is what makes your urine smell. Anyone and everyone that stinks like urine will never be in a solid relationship, okay? And then nitrate, which is NO3 minus. No, I don't want to be in a solid relationship. So that's how I memorize it, but whatever floats your boat, okay? Do what you got to do to memorize these. So here's an example. So for instance, if I have sodium fluoride, NaF, sodium is part of the Lena column, right? And therefore, this whole compound is going to be in aqueous solution, okay? And it's going to be a soluble compound, okay? All right, let's continue with the second one. The second one is when they are always insoluble. So the ones that are insoluble, it means that they are always going to be in a solid state. And it just so happens to be AP history compounds. AP History and Chemistry, they don't really like to go together. So AP History decides to just leave the dance room, right? So AP History, it's AgPbHg. So silver, lead, and mercury are never, ever, ever going to be part of the dance pool. They are always going to get married and leave the dance pool because they are in a solid relationship. Okay, so here's an example. AgCl. Okay, so again, if you look, silver is part of rule number 2, and therefore it's always going to be a precipitate, a solid. However, if any one of these AP history elements pairs up with any one of these rule number 1 elements, like nitrate, they are always going to be aqueous. Rule number 1 takes priority over rule number 2. Okay? Cool. Rule number 3. Rule number 3, these ones are slightly soluble. Okay, slightly soluble. So these ones are almost never soluble, okay? And the way I memorize them are pakasur, pakasur, okay? Pakasur. So pakasur plus halogen, okay? It's not really good. There's actually a drink called pakasu in Korea, which is kind of like Red Bull or like one of those energy drinks. Pakasu kind of sounds like it, right? But anyways, all I tell my students who actually know Korean or not, whatever, or know the drink, if you put water in bakasur, you're diluting the energy drink, and that's not really good, right? So you don't want to do that. So it doesn't really like to like dissolve very well, unless it pairs up with a halogen. Okay, and so what happens is bakasur, like for instance BaCl2, because Cl is a halogen, this will dissolve, so it's aqueous. And bakasur pairing up with rule number 1, because rule number 1 is going to be always top priority. So for instance, like with nitrate, this is also going to be aqueous. But what about if you have something like this, BaSO4? BaSO4 must be memorized. This is a regular on the AP as well as the SAT2 as well as high school chemistry exams. BaSO4 is not part of rule number 1. It is not a halogen, so hence it will be a solid. Okay, so this one must be memorized. Got it? Got it. All right, now let's continue to the last one. This one, there's no real scientific proof to it, but I just use it for like worst case scenarios, and it's just the sum of the absolute value of the charges of the ions that are getting together. If they're greater than or equal to 4, they happen to be a solid. So this one, please don't ask your teachers or your professors why this works, because it doesn't really work scientifically. It's just a pattern that I have seen, and it just helps you get through an exam. Okay, so for instance, like FeSO4, okay, iron sulfate. Let's just assume that the iron is a 2 plus charge and sulfate is a 2 minus charge. So what you do is you just get the charges, and I am just going to add the absolute values of them. Okay. Oh, look, this is greater than or equal to 4. So if it's greater than or equal to 4, that is most likely going to be a solid. Okay? Easy peasy? Easy peasy. Now that you know how to do these, let's do an example, okay, of a double replacement reaction. So for instance, if I have silver nitrate, okay, aqueous, plus potassium sulfate, what I'm going to do first is I am going to look at these and I'm going to say, okay, so it looks like all of these are ions, right? So what I'm going to do is I'm going to actually just write its charges just to make my life easier. Okay, so I know which ones are going to be pairing up with which ones. So outside with the outside, inside with the inside is going to be how they are going to be usually paired up. And so if I look, Ag, which is a positive 1 charge, and SO4, which is a negative 2 charge, they swap them and drop them, right? they do the swap and drop, okay? So when they swap and drop, you end up with Ag2SO4 1, right? Plus, I have potassium and I have nitrate, and potassium is a +1 charge, nitrate is a -1 charge. Again, you swap and drop, and you see it's a 1-to-1 ratio. Obviously, the ones there, it's kind of understood, so you don't really care, right? Okay, so if I were to rewrite this, AgNO3 plus K2SO4, it's going to yield Ag2SO4 plus KNO3. Now let's look at the rules. If we were to look at the rules, okay, from up here, let's look. So silver sulfate, Ag, this was part of the AP history, rule number 1, right? Oh, look, Ag, unless it pairs up with rule number 1, it's always going to be what? A solid. And let's look at KNO3. Potassium is part of the Lena column. Nitrate is also part of rule number 1, which says, no, I don't want to get married, right? I don't want to be in a solid relationship. So this is going to be aqueous. So aqueous are still going to be floating around in water, and these are going to be called the spectator ions. Okay, so if they were to ask you to come up with your net ionic equation, your net ionic equation will be silver ion plus sulfate ion yields Ag2SO4, which is a solid. All we want to know is who is the star of this chemical reaction? Who is getting married? AgSO4 is getting married, right? Ag2SO4 is getting married. Who is going to be the spectator? Who's going to be a spectator at the wedding? These ones are going to be the spectators at the wedding, okay? So hence, this right here is called a net ionic equation. Okie dokies? Okie dokies. That's it. Now, there's actually another part to double replacement. Double replacement can be either a precipitation formation type of chemical reaction, right, where you're creating or determining precipitation. But the second one is when you have an acid and base. Okay, so let's do the acid and base really quickly and let's call it a day. So the acid and base, the way it works, the acid and base in double replacement, from what it is, an acid at this level is anything and everything that is paired up with a proton, okay? A base is anything and everything that is paired up with a hydroxide, all right? So here's an example, okay? Here's an acid, HA, plus here's a base, BOH. So what happens is outside with the outside, inside with the inside, we switch partners, we end up with AB plus HOH. Please don't write HO. It's water, guys, right? 2 hydrogens and 1 oxygen, so it's H2O. Okie dokies? So we end up putting an acid and a base, and we end up with a salt and water. All right, so let me give you an example. The example would be sodium chloride, sodium hydroxide, and then we switch partners outside with the outside, inside with the inside. We end up with NaCl plus H2O. And obviously, this is salt and that is water. That is it. So I know this was a lengthy video, but I hope you guys learned something, and please don't forget to subscribe. And if you guys have any other comments, if there's any other topic that you guys want to see, please write it below, let me know, and I will create a video for it. Okay? Thank you. Bye, guys.